Huh. Do you guys know that water makes up 70.9% of the Earth's surface and that our bodies are made up of 90% water?
What?
Really?
No way.
Wow.
No way.
No way.
That's crazy.
Wow. I wonder why it's so special.
Hey guys, I'm Winai the Water Guy. What do you want to discuss today? Water!
Phil, why is water so special? I've heard that it's a universal solvent, but what does that mean?
Almost every extraordinary property of water is due to hydrogen bonding. Enoch the water doc will explain.
Okay. Connie is an oxygen atom, and Tyler and Johnny are hydrogen atoms, which is covalently bonded, meaning they share electrons. However, Connie is stronger and pulls more electrons away. That makes Connie a little negative, and Johnny and Tyler a little positive. This means Connie is a little attracted to positive particles, and Johnny and Tyler are attracted to negative particles. This attraction is called hydrogen bonding.
I still don't understand.
I don't see why that makes ice float on water. How can ice float?
When water freezes, each water molecule is held firmly in position due to straight hydrogen bonds. This gives ice a very rigid structure with a lot of space in between the molecules. This makes solid ice less dense than liquid water.
So you're saying that liquid water has less hydrogen bonds per molecule than ice, making it more dense, correct?
Yes, that is correct. Ice can have 4 hydrogen bonds per molecule, and liquid water only has, on average, about 2.3 hydrogen bonds per molecule.
What else does hydrogen bonding do?
Well, surface tension causes a lot of things. Can anyone tell me what surface tension is?
Tyler. Surface tension is a liquid's resistance to spread out and increase its surface area. I believe it's caused by the difference between the forces experienced by molecules on the surface and those experienced by the molecules in the interior. Is this correct?
Exactly. Surface molecules are less stable than the interior ones. Thus, liquid acts to minimize the number of surface molecules. This reduces surface area, creating surface tension. Let me show you guys a couple demos. This demo is going to show the amazing surface tension properties of water. How many drops do you think can fit on this penny? One cool effect of hydrogen bonding is the phenomenon of capillary action. As you can see, the water molecules are able to move up our tree of science against gravity. Any other questions?
One thing I've always wondered is why it takes water so long to boil.
Due to the hydrogen bonds we learned about earlier, water has extraordinary properties when it comes to transitions between phases. This is a 3-phase diagram. Here is solid, liquid, and gas. And these 2 straight lines in between are the transition phases. Water is known for having both a high melting point and a high boiling point. Can anyone tell me what those are? Jessica.
Well, the melting point for water, which can be defined as the temperature at which solid and liquid water are at equilibrium, is 0 degrees Celsius.
The boiling point for water is 100 degrees Celsius, meaning that it is the point where water and gas are at equilibrium.
Great. So let's label these 0 and 100. Johnny.
But what about those horizontal lines on the graph? You said they were the transition sections? What does that mean?
So this section is the heat of fusion. It is the quantity of heat required to completely melt 1 gram of substance once it has reached its melting point. For water specifically, it has a very high heat of fusion. Can anyone tell me what the other horizontal line is? Connie.
But isn't that the heat of vaporization? The quantity of heat required to vaporize 1 gram of liquid once it has reached its boiling point. In fact, water has one of the highest values, explaining why water evaporates so much slower than other liquids.
That's cool and all, but what does it mean?
Well, since water characteristically has such high values for melting point, boiling point, heat of vaporization, and heat of fusion, it takes that much more energy input to see any transitions in state. This is why it takes water so long to boil.
I thought it had something to do with specific heat.
In a way, specific heat does relate to why it takes so long for state changes. Can anyone tell me what specific heat is?
Specific heat is the amount of heat needed to raise 1 gram of substance by 1 degree Celsius.
In fact, water has the highest specific heat of any liquid, giving it the capacity to absorb a large amount of energy without changing temperature.
Exactly! And this is why so much energy must be put in, because water can absorb such large quantities of heat before transitioning. I have one more awesome demonstration to show you guys. Come take a look.
It absorbs so much energy.